Hello, today we're going to talk about vectors, which we kind of know a little bit about already. A vector is basically a quantity that can be characterized by its direction and its magnitude. So both of those things we've talked about in the past. A direction tells us which way something is moving, and a magnitude tells us how much it's moving by. This symbol right here is what we use to notate a vector. Kind of looks a little bit like a ray, but you can't mix it up with a ray. It's different. It doesn't represent a piece of a line. It represents a direction and a magnitude. So it has a different meaning than a ray. Okay, so to understand what a vector is, I'm going to ask you to draw an arrow from A to A prime, and use your ruler when you do this so that it comes out nicely. Okay, this arrow that you just drew is a vector. Okay, it describes the movement of our pre-image to our image. It's telling us the exact direction that we're moving, and it also tells us the magnitude. We could find the magnitude just by measuring. So from A to A prime, it is 7.7 centimeters. So that's our magnitude, and our direction is this way. We don't really have a way to describe the direction because the arrow itself tells us which way to go. Okay? So let's say I didn't give you the final image and I just wanted you to figure it out based on a given vector. That would be like example number 2. Okay? So again, this vector shows us the direction we want to move our shape, and we need to just measure it to figure out how far to move it. So this vector is 2.3 centimeters, and I cannot move my ruler when I do this. I need to keep it in this position. All I need to do now is just to kind of slide it over to each point. Okay, so be very, very careful when you do this. It should still match up with this direction. Don't move your ruler from side to side because then it won't be the right direction. Okay, so now I'm going to measure 2.3 centimeters. That's going to give me B prime. And I'll fill in the arrow later. Move my ruler over to A. Be very careful. Again, 2.3 centimeters, so A prime. I'm going to fill in my arrow here. Move it down to D. D prime. And last one is C. C prime. Okay, now you can move your ruler because we've got all 4 points. We want to add an arrow to show that this was moved by a vector. And then the last thing we need to do is connect the points so that it has the same closed shape that we started with. Okay, now some of you will look at this and say, oh, it looks like a box. Be careful because we're not really creating a three-dimensional shape. We're just using these vectors to get to our final image, which is this one right here. Okay, so these vectors just describe the movement. Yeah, it kind of looks like a box. If it looks a little bit crooked, then you know something went wrong. So it should look like this. Go ahead and flip to the back of your paper, and now we're going to see what happens when you have a vector that's not given to you separately, but it's actually a part of the figure. So my vector right here is AC. That means my vectors starting from A and going in the direction towards C. So this right here, this side, is basically my vector. Okay? So I know I need to move this whole triangle. I'm sliding it down to here. Now I just need to see how far should I be sliding it. And it looks like exactly, our magnitude is exactly 2 centimeters. Okay? So since this is really nice, I'm just going to measure 2 more centimeters, so down to 4 centimeters. That's going to be C prime, so C down to here, C prime. If I move A 2 centimeters in this direction, it's going to line up perfectly with C. So here's A prime, here's C prime. Okay, now I got to move B. B is tricky because I have to, again, make sure that I, whoops, don't move my ruler like that. So I'm going to slide it really carefully over to B. 2 centimeters. That would give me B prime. And again, I want to draw my little arrow to show I used that vector. Okay? Same as the last problem, I'm then going to connect my 3 points. So my final image should look exactly like the pre-image. The only thing that we're doing to this is sliding it by a given magnitude and a given direction. Okay, so this is how you're going to translate figures given a vector using a ruler and a pencil. Let's say I wanted to use vectors on the coordinate plane. On the coordinate plane, it's actually a little bit easier because you don't have to worry about moving your ruler from side to side. So first of all, let's get through the notation. There's 2 different ways that you could write a vector on the coordinate plane. The first one is component form, which kind of looks like an x and y paired coordinate, but instead of parentheses, we have these little symbols here. So just like your xy point on a coordinate plane, A here represents the horizontal movement, and B kind of goes along with Y, so that is the vertical movement. Okay, so that's the component form using these symbols. Coordinate notation looks a little bit more like a coordinate point, and then we describe that this is a vector with this capital V. So we put V equals parentheses A comma B, close your parentheses. And A and B still mean the same thing. So A is horizontal movement, B is vertical movement. Okay, when you're looking at the movement, it's important to know if you're moving in a positive direction or a negative direction because the sign does matter. So here's an example. Write the vector that describes the translation 4 units right. So going to the right, that would be in a positive direction. And 2 units down, that would be in a negative direction. Okay? So component form, that's the one with these symbols. So I would set it up for yourself kind of like this and say, well, 4 units in the positive direction, that would just be positive 4. And then vertical movement, up or down, 2 units down would be negative 2. Okay, coordinate notation is going to be very similar. We put V equals 4 comma negative 2 with parentheses. Okay, so this is just to get an idea of what the notation looks like. Now let's put it on the coordinate plane. So we've got this shape QRST, and it's moving or translating in this direction to Q prime, R prime, S prime, T prime. We want to describe this translation using both the component form and the coordinate notation. So again, component form, that's with these symbols. So now I want to look at my horizontal movement. It doesn't matter which letter you pick, just pick one because they're all moving in the same way. So I'm going to start from T. It's going up 2, and it's going to the left, which is negative 1, 2, 3, 4, 5, 6, 7, 8. Okay, so my horizontal movement to the left 8 or negative 8. My vertical movement is going up 2, so positive 2. And then similar idea for coordinate notation, capital V for vector. This vector is equal to a horizontal movement of negative 8 and a vertical movement of positive 2. So in the future, you should know the difference between component form and coordinate notation, and you should understand that they mean the same thing, they just are displayed using different symbols. Okay?